All right, I'm Chris, this is Matt. We're giving this talk, Living Off the Land, a Minimalist Guide to Windows Post-Exploitation. So what we're actually talking about is the fact that defense is real. We heard this morning, blue teams are getting better, right? You guys are all here. Just by show of hands, blue team, awesome. Blue pen testers, very blue pen testers, admins, awesome. So, well-trained network defenders and admins, the blue teams are getting a lot better. So, really, it's kind of like up your game. What's the next step? It's actually the use built-in tools, not introducing things into the environment. So, we're going to talk about WMIC, NetSH, and something that we're kind of fond of, Windows PowerShell. So, if you're not in the right talk, all right, so again, I'm Chris, this is Matt. In addition to all our stuff, I'm from Augusta, Wayside. So it's great to come back and talk to you guys today. The blog, my blog is obscuresec.com, and Matt's blog is Exploit Monday. Exploit Dash. All right, so what is homesteading in an enterprise? What are we talking about? We're talking about post-exploitation, right? We've already delivered our payload. We've sent a phishing email. We found some web exploitation, web vulnerability, and exploited that. We're in the enterprise. How do we stay there? How do we avoid detection? How do we live there for as long as we can, get as much data as we can? And really, that comes down to living in memory. The more you write to disk, the more likely you are to be caught by antivirus or other software that's actively looking for new or strange things. So we use the tools that are already there. We use the protocols that are actively being used so you don't stand out on the network side either. You don't talk when the network is quiet. So if you see things going on at 3 o'clock in the morning because you have your interpreter checking in at 3 o'clock and then 3:30 and then 3:45 and they come in the next day, that's a really easy way to get caught. And another thing that I like to do is use their infrastructure. If you're an attacker or a red teamer, use their infrastructure against them. Command and control from their servers. Use what they are using. We'll talk about that in this talk.
All right, so throughout this talk, we're going to be talking about the traditional way that pen testers would do things, which is the minimalist way, which is generally the way Chris and I do stuff on a pen test. Now, I just want to preface everything just because I'm describing something as the traditional way that a pen tester would accomplish a task in a post-exploitation environment. It doesn't mean it's the wrong way. And you're still going to see the techniques that we describe as the traditional way all the time as a defender, right? All right, so in your traditional post-exploitation environment, what's a pen tester typically going to do? Well, they are most likely going to want to upload binaries, right? So they're going to do everything that they can to avoid antivirus. So say they want to run an interpreter payload, right? It's really easy to generate from MSF console. You run your executable, you run it through an encoder a bunch of times. Say you run it through the Chicago Ganagi encoder 1,000 times, hoping that it won't flag antivirus. Well, that's effective some of the time, but the bottom line is you're still running an executable that's on the disk, potentially susceptible to being caught. There's Mimikatz, which is a fantastic tool. I love it. It's designed to capture passwords in memory. It does a great job at it, but again, it's also a binary. So in the case where I would want to run Mimikatz, I would want to do it offline. So there's actually a new feature in it that allows you to analyze Windows crash dump. So you get a crash dump which you can get as a user with no elevated privileges and pull passwords out of memory from the lsas.exe crash dump. And there's actually a tool in Powershell, which is our post-exploitation framework, Powershell, that will generate a crash dump as privileges. So you can certainly upload scripts, BB script, and back scripts that have been around forever, 20 plus years. They certainly have their place, but you do have to drop those scripts to disk. VB scripts, I would say, is only slightly more powerful than bash. I like to say that VB script is just bash with access to compound things, so just slight additional functionality. But again, you have to drop the disk. Now, in minimalist post-exploitation, you're staying resident in memory using the existing tools on disk. So two of the tools that I really like to use built in, besides PowerShell, are WMIC, which allow you to exfiltrate a ton of data from the network, and NetSH, which allows you to do the same thing, but you can also pivot your NetSH and WMIC as well. And then, of course, there's PowerShell. So with VBScript and that, again, you have to drop everything to disk. With PowerShell, you have that option, but you also have the option to run everything in a one-liner from a command line. And I'm going to talk about how Chris and I do that. All right, so a little bit of background for PowerShell. Quick raise of hands. Who here has used PowerShell? Okay. Cool. So you're probably already familiar with how powerful it is, but as an attacker, it's awesome. So it's one, a scripting language. Two, it's also a .NET interpreter. So you have the entire .NET framework library available to you, which gives you access to, say, creating sockets, using crypto libraries, but it also has a cool functionality called p-invoke and reflection, which allow you to get to the low level and execute the low level payloads that, say, your traditional executable would run. So if there's a binary that you want to execute on this, there's absolutely no reason that you can't do that in PowerShell. Right? And again, no need to execute anything from disk. And so VBScript and bash, again, it's not as powerful, doesn't give you native execution, and it's often flat-fired. Right? Execution policy. So whenever I talk to anyone about the offensive uses of PowerShell, they're like, well, I can block all that with the execution policies, right? Because that's just going to stop all of your malicious scripts outright. Well, again, I said you can run everything from a one-liner command line, completely bypassing the execution policy. So what is the execution policy? By default, in PowerShell, it has the restricted execution policy, which makes it so that basically you can only run scripts that are signed by Microsoft. Well, Microsoft gave you the ability to just provide the bypass switch on the command line. So Microsoft's mentality was, it's not a true, robust security feature. Really, the intended purpose of it was to prevent unintended scripts from being executed. So if you got a phishing email with a malicious PS1 script, and some dumb user decided to double click on that, well, for one, it's not going to execute, and two, by default, the default file association for PowerShell scripts is Notepad. So it's just going to open up the content of that script. Right? So it's really trivial to bypass it. As I said, you just do a Reddit command line. In fact, you type the word bypass into PowerShell.exe. There's a really awesome feature, which Chris and I use all the time, where you can base64 encode your commands. And so you just provide everything on the command line. So that does provide like an additional layer of obfuscation. You even want to call base64 base64 encoding obfuscation thing. But it is really nice just to kind of help hide the tracks. And it does enable you to have really complex scripts, thousands of lines compressed into a single base64 string that you provide in the command line. So this example here is pretty cool. It's not a well-known trick where if you're in PowerShell and you do cmd/c echo and then you give your PowerShell script, it'll automatically base64 encode for you. Because otherwise you'd have to use some .NET classes to encode it. That just automates the process for you. Alright, so how do Chris and I prefer to do it? We prefer to use PowerShell as a command stager. So think of it like the equivalent of using curl to download your payload on a Linux box, and then dot sourcing whatever your malicious script is. This is the equivalent of that. So IEX is an alias for invoke expression, and all we're doing here, there's a .NET class, and we're calling the download string method, which is going to download our malicious script, and then IEX is going to execute that. Simple as that. So what this allows is malicious scripts of an arbitrary size. Because at the command line, I believe the character limit is what, 8,192, something like that. So if you have a large malicious script, there's a lot of them in PowerShell, but this is probably the way to go.
Manually invoking that, or JavaScript, or some other things? How are you running that command?
Okay, we'll talk about a couple different ways that we can do that. Going back to what he discussed before, so for phishing emails, I like to send macros, and my macros now are really, really simple. It's just VBA that is executing one, so it's 4 lines of VBA in the macro, and all it's doing is then executing the stager. So that's all it's doing. The actual payload is not in the VBA, just the download. It's PowerShell stager. So that's one way.
So here's an example of the typical payload that you want to execute once you compromise the machine. You want to get a bind shell. So what is a bind shell? It's a payload that essentially listens for network commands, and once you connect to that compromised machine, you get a command prompt. So there's a lot of ways to achieve that. If you were masochistic, you could certainly write your own shell code, write your own payload. There's a lot of built-in bind shell payloads in Metasploit that you could output as an executable. If you could run netcat, that still works great. There's no reason not to use it if you're not worried about antivirus. If you are worried about antivirus, we do happen to have a script that helps bypass byte signatures for files like this. So that doesn't help get past your signatures, but it will get past byte signatures. Yeah, I've been doing some shellcode research recently, and I did develop just a proof of concept bind shell that when I compile it for C, the x64 version does not flag antivirus. So if there was a bind shell executable you do going on, you may want to check that out. I ran a virus code and it doesn't even glitch.
Okay, so we talked about the way, the traditional way of getting a bind shell. So a bind shell is something listening on the target that you can send commands to, and then it returns stuff back to you. So you can come in, most of the time anyone can come in after you. So bind shells are typically not good for pen testers, but attackers use them all the time. One simpler method without authentication is if you compromise a box that has remote desktop, and you are able to get to system level privileges, you can copy cmd.exe over the sethc.exe in system 32. And then from that point on, if you ever want to connect back to the box, you connect over 3389 through RDP, and you send the shift key 5 times, and then a command prompt as system will, you've not logged in, you've not created any logs, and you've got a system command prompt, which has worked in some rare cases. So a quick note about that is NLA, which is in the latest version of mstsc.exe, the remote desktop security feature that requires authentication before connecting, so requiring you to authenticate before it gives you the actual command to log in. You might want to enable that for this reason. Invoke HTTP backdoor. I've got an early version of it on my GitHub. Eventually, I will meet the strict coding standards of Matt's PowerShell project, and it'll get moved over there. I've used it a couple times. If you've seen, I've talked about hacking appliances. I like to get into Linux boxes first because they sit out on the internet, and then I'll use those to go after the Windows boxes. So one way I'll command and control the Windows Enterprise from, say a cheap proxy or something that's sitting out there on the internet is with this HTTP backdoor. So it's just using a .NET class to start up an HTTP listener that will receive commands, and there's a little bit of authentication I'm working on. And there's some encryption with HTTPS and pre-shared AES key. But currently, in its proof of concept form, you can send commands. So that's an example of sending it who am I and host name. You just base64 encode the command, and you hand it as a session. So you can use curl, wget, whatever, a browser if you want to, and it works just like a web shell on the boxes. So you can deploy this out and command it that way. But the biggest thing with that is you're not, in both of these cases, we're not introducing any new binaries, even though we're overwriting something which is detectable, and we've got a new port listening, also detectable, but we're not adding a new binary that's now listening that can be found by AV. None of the things we're suggesting are foolproof or magic ways. There are always going to be ways to detect this stuff. So we're trying to push on the blue side as well to start looking beyond, did a new DLL get dropped in System 32? Did a new executable get dropped in all user startup? Look beyond that to other things like where did this port, this listener show up? And then maybe start looking at memory forensics that way. All right, so privilege escalation. So pen testers, how do you normally do a privilege escalation on a Windows box? Say you send a phishing email and you get user. Get system, right? Everyone uses it. It's awesome. Does everyone know what get system is doing in Interpreter? Get system is a post-exploitation command in Interpreter where you basically just type get system and then it tells you got system via one of, I think there are up to 5 techniques now. In this case, it's technique 4. So 4 is actually Kitropod, which is an old privilege escalation exploit. So it's trying local privilege escalation exploits, and then hopefully you get it. It does little silly stuff like schedules a task using the old task scheduler method. It does all that stuff for you, and it's generally pretty effective. Another one I want to plug is Srb Check, which is kind of old, but it's checking for bad service permissions that allow a standard user to stop a service, replace the binary, and restart it. So services generally run a system. So that's an easy way to do that. By default in XP, XP with no service pack and service pack 1 had system services that were vulnerable. Now you really only find like third-party stuff.
Your super easy mode get system there, is that usually effective against a fully patched system?
No, absolutely not. If you're a pen tester, you have ran into multiple cases where not only is get system not worked, the AV product is saw that exploit, flagged it, shut your shell down, and you're done. So I don't typically ever run get system on anything but like CCDC or like capture the flag events. Because most IPs, most modern products are going to catch one of, specifically Kitropod, one of the ways that it's trying to privilege escalate.
We would certainly prefer to exploit misconfigurations versus vulnerabilities in binary.
Right.
Just because those are more susceptible to being called by AV.
So
And it's easier.
going back to the whole minimalist thing, all of this stuff we're trying to do without exploits. I mean, the majority of enterprise compromise can happen without ever throwing a single exploit. So instead of trying to throw exploits, Kitropod for an example, why don't we just go look for passwords? So this, it's unbelievable. If you're a pen tester, you know this, but if you're not looking for passwords in your enterprise and you decide to do it on Monday, you're gonna find a domain admin password somewhere. And it's gonna scare you to death. But that's really probably 90% of the actual privilege escalation that I do comes from these methods. So unattend.xml, lots of different deployment scripts that are out there. People are using PowerShell now and baking in the scripts, or baking in the credentials, which is terrible. Get GPG password. Does anyone know what, has anyone seen group policy preference passwords? A couple people. So the rest of you, we're going to do a demo here in a second, and you're going to be shocked with this awesome feature they introduced in early 2008. And then here's another method that was very effective when we were on the Army Red Team. One of the other operators suggested this, and I thought it was a terrible idea coming from Windows enterprise background. Well, let's just guess passwords. So let's just look at what most people are setting the passwords. So we have these long complexity requirements, 16-character passwords. You know, we've got to have all kinds of crazy stuff in there. So he was like, well, what are the odds someone's going to use a keyboard pattern? So now all we need to do is do some recon. There's going to be a great recon talk later. Do some recon, come up with the names of all the admins. Use that with this common password, this keyboard pattern, this password 1, 2, 3, 4, whatever. We'll take one password, try it for all the users. And I know of at least probably 10 examples where the first day we were done because we did that. Yeah, we generated a lot of logs, but we only tried one password against every account. So we didn't lock any accounts out, and we got one. And that's all you need. So you get one, you move on from there. So guessing passwords is insanely effective. So we're going to do a demo. So this is a low privilege domain user logging in, right? They're just showing up for the day and they're like, oh, I want to install this really cool thing I installed at home, BNC. Everyone know what BNC is? Because I want my desktop at home. So we're going to go ahead and try to run it, but users who want to install BNC typically don't have admin privileges, hopefully. So Mr. Normal User is going to try to log in. It doesn't have admin rights because we don't give admin rights to everyone, right? So, group policy preferences. So now we're enforcing the same password on every single box, which is a nightmare for attacks like pass the hash. But with this great easy feature that they originally plugged, everyone should be doing this. We can enforce with group policy, which group policy is awesome. We can make sure the same password is on every single box. So Mr. Normal User has heard about Powershell somehow. He's one of the 8 and decides that he's going to download get GPP password, which is just a PowerShell function. So even though they're all .ps1s, we don't ever call them. They're just functions. You've got to call them yourself. So he's going to open up, as a normal user, open up PowerShell and a simple bypass. So he runs who am I to just make sure he didn't magically get admin rights. So then all he's going to do is copy and paste the function. So we're going to dot source it essentially, paste it into the interpreter. The interpreter does not enforce your execution policies at all. So now we can call the function, and that's all you have to do to run this. There's nothing you have to pass as a parameter, and then bam, he sees that the admin password, the admin username is changed and has presenters, and the password is recycling times 3 for the win. So he goes back, he can now try the admin username and password, and you have no way to log who did it other than who simultaneously logged in, but you really don't know who did this. And there are a lot of enterprises that this is deployed in, and they have no idea until a pen tester shows up and does this to them, that it's this easy for their admin password to be discovered. The other thing that if you go on Monday and you disable this, great. Also go to the domain controller and go get the old group policy object where the password is encrypted with a pre-shared key that they have on TechNet. Go delete that, because your old password could be as valuable as your current password if there's some sort of trend or some box that doesn't get pushed to. So, right, a normal user is just going to install BNC, but we're going to take that and immediately push out through a method that Matt's going to talk about, push out actual PowerShell, push out interpreters, push out whatever we want to every single box that password is on.
Maybe this is a stupid question, but why does your normal user have a public IP address they can expose BNC in the first place?
That was just a demo. But there are lots of organizations that do stuff like that.
I can think of one Fortune 500 I worked in where every desktop had a public IP.
Right, exactly. If you've seen any of the new hyper-fast scanner software that's out there, they can scan the whole internet. What is it? ZMAP, right. So ZMAP, you can scan one port in the entire internet in a couple hours from your standard home box. I think it was University of Michigan guys, but they found there are hundreds of thousands of BNC boxes on the internet right now. And if you don't know, BNC, old BNC is vulnerable to authentication bypass, so you can just propagate into any of those boxes and take over their stream, which is
lots of times we actually use that.
Yeah, well, it's just insane going back for years to this day. We still, 5,900 scan, 5,800 web version, and see it bypass it. And you're the user, so then we'll show you exactly what we do at that point. In 2 seconds, we have a show. And we'll show you that in a second.
Residential networks, there's a surprising number of completely unauthenticated BNC over the world too.
Exactly. All right, so port redirection. So what are we talking about port redirection? You get on, say you pop up a website and you're on a box that's in the DMZ and you you want to pivot through it, say it's a Windows box, and you want to pivot through it, something you can access a closed port from the internet or from somewhere else, and you want to use that to then pivot in. So you use port redirection. So what do anybody, you see this list, any pen testers use anything else to accomplish that? I mean, those are pretty standard tools that have been taught in different pen testing classes. But most of them still work. So you set up the box to listen on, say 443 is closed on the internet. You say forward this to this remote 3389, and then you just connect through RDP from the internet. Well, you can do it with a tool that's already there. NetSH will actually do this for you. I found this in Windows documentation several years ago. It's been talked about at a DerbyCon talk a couple years ago. Chris Gates and Rob Fuller talked about it in their talk. But it's that easy to set up on a Windows box for it to listen for any connections. So now you can start playing with admins and network defenders. You can start pivoting and redirecting all your traffic around. So in one case, I actually used 3 redirections because they were so actively killing us. So we would do that, then they would catch it, and we'd redirect through something else. But once we got domain admin, there really was no way for them to figure out where we actually were persisting. We were only persisting on one box. But through redirection, by doing this remotely through WMI, which Matt will talk about, we were able to set these redirections up all over the place, and it made it very difficult to detect.
All right, so you may want to deploy a keylogger as well. You may want to capture passwords. See what network resources people are going to. Right, pretty self-explanatory. There's plenty of payloads out there that will do keylogging for you. Majority of them are binary executables that you drop off disk that are going to be flagged instantaneously by antivirus. Some smart people wrote out their keylogger in C#, which is generally not as susceptible to being caught by antivirus. For whatever reason, AV just does not have the introspection into managed executables as they do unmanaged, like raw native executable binaries. So if you're thinking about writing malicious payloads, C# is definitely a way to go. And that's essentially all we utilize in PowerShell. It's not C# but .NET to bypass the same thing that say C# payload would bypass. So what does a keylogger typically do? Like, how's it implemented? Well, most of them typically just are in a polling loop, calling the function get async key state, like just to see which keys happen to be depressed at that polling interval. There are more advanced ways to do it. There are better ways to do it. But for example, you can call the function set Windows hook EX, but that requires that you drop the DLL on this, and you can't do that. So essentially, all Chris and I did was just implement that same logic, that polling logic of calling get async key state, and did it in PowerShell. So we're not dropping anything into this memory. All right, so running in memory is great. Do it as long as you possibly can. But at some point, you're probably going to want to survive a reboot. So that's why you want to persist. So there's plenty of ways that you can persist. You can drop an executable or a script into the all-user startup directory. You can modify registry keys so that your payload runs every time you boot. There's the ad scheduler, SCH tasks on, I believe it's Vista 4 machines to get your payload running. Well, those are all insanely easy to detect. You just run the systemterminals auto runs tool, and it'll show you all of those persistence mechanisms. So my aim was to develop a technique that uses PowerShell to persist on the network without being detected via normal means. And I'm using WMI for that. So it's not very well known, but there's actually a system, or there's a service that runs as system that is constantly polling for commands to execute. All you have to do is use WMI to register an event that when that event is triggered, it fires, and you also have to register a consumer to execute your payload. So that's what I'm using Powershell to accomplish, and this technique is not detected in auto-run. It uses some relatively obscure WMI syntax. There's a whole language within WMI, it's called WQL, WMI query language, to accomplish this. The first time that I ever heard of this technique being used was with Stuxnet, only they were using it to get privilege escalation. So they had an arbitrary file write vulnerability, and so they could write anywhere on the disk. So some really smart people figured out that if you drop, it's called a MOF file, it's basically a compiled payload for WMI events and descriptions. If you drop this specially crafted file into Windows System 32 WBEM, that you would hit that polling loop that runs as system, and then you get code execution. Well, I'm using that same polling mechanism just to get persistence. So what I'll do is I'll use the WMI event subscription to detect when your system has been booted for 5 minutes, and then it'll just go ahead and maintain a system. Okay.
All right, so the last thing, kind of something I've talked about in other talks on the persistence. So if you dump hashes and you have all the credentials, really, if there's any way to authenticate with those credentials from the outside, from the internet, there's no reason to actually persist. You can come back in whenever you want. So there's a VPN, BNC, RDP. If any of those things exist, there's no reason to persist. You come in when you want, take what you want, and you leave. You don't leave anything behind. So once you dump the hashes, has anyone seen the Pass the Hash Firefox? It's in the Pass the Hash suite. It's in Kali, it was in Backtrack. So a buddy of ours wrote that. Basically, he patched Firefox to take a hash instead of password. So once you dump the hashes from the domain controller, you come back in and you can authenticate to OWA, SharePoint, anything that has NTLM SSP pushed out to the internet, you can come back in and authenticate that way. Just imagine how easy it is to have persistence when you can log in as the CEO into OWA that way. Citrix is another example of ways of persisting without actually uploading anything or leaving anything behind. All right, so packet captures. Packet captures are awesome, and I've used an interpreter packet capture utility for a long time. There are a couple ways to detect it. I've been told on red teams, someone's called in incident handlers and they've detected that specific thing. Not really familiar with all the ways that it can be detected, but it does a great job of giving you packet captures once you've elevated privileges. So capturing all the packets, sometimes you're not just getting the authentication of the box that you're on, you're also seeing other things going across the network. You can catch things like NTLM v2 credentials coming across. There are lots of reasons why you would want to do a packet capture. If you're doing web exploitation, you get on a Windows box, you can then see all the users authenticating. You're using basic authentication at that point, you're just collecting credentials. I was on a pen test with someone that installed WinKitKat. I would generally never do that, and I'll show you why I would do that. But there are some classes out there that teach that installing WinKitKat from the command line so that you can do packet captures. It leaves a huge forensic footprint, should be pretty obvious. There's a Windows packet capture utility. Anyone know what it is? Not NetSH, but something else. Netmon, there we go. All right. So Netmon is Microsoft's packet capture utility. Windows admins seem to not really know about it. Occasionally I see it deployed. If that's there, use it. You don't need to use NetSH. Just use that tool. It's typically only on servers. But this is pretty cool. I was helping somebody work through an incident handling scenario where they actually were tipped off that the red team was there, which you should not be doing. But he was tipped off, so he kind of figured out the box that they were on. And he was like, how are they on this box? So he didn't want to tip them off, but he wanted to do packet captures. He didn't want to install anything on the box. So this is what we settled on doing in that case. But it has obvious offensive uses as well. So you just create a capture with NetSH, and you can do full packet captures without.
What format is that in the?
It's going to be in .cat, and it's actually going to have some interesting extra data. So if you want to open it up in something other than netmon, so you have to basically use netmon to view the data. If you want to open it up, you can output from netmon to XML, and then strip the extra trace. There's 2 extra fields. Strip that out through either Python, or I use PowerShell to do it, and then it's very painful, and then you end up with something that Wireshark can import at that point. Yeah.
So the reverse shell is ideal to a blind shell. What it does is it calls out over the network to your listening machine and shovels your shell over to the box that you control. And the reason that's better is because it'll bypass bypass firewalls. So you could shovel your shell over 4.3 or 480. The same problems apply. If you want to execute your payload, you may want to do that by dropping a binary. You're going to run into AV again. You could hack your binary. Those are triggered all the time. For example, the UPX binary, it has the UPX string in the sections, which are easily flagged. So it would be flagged as suspicious. A lot of AVs now are just analyzing the entropy of an executable. So if the entropy of your binary is too high, it's just automatically getting flagged as suspicious. You can certainly generate your own custom binary, and Veil is an awesome tool to achieve that. So in one of the configurations, you can package your payload into the Python interpreter, and that, to my knowledge, has not been caught by any means. The mere fact of running the Python interpreter with an embedded payload is fine. So you can do the same thing in PowerShell, only you're not going to be touching with this. So I wrote a function called invoke shellcode, and I added some Metasploit functionality to it. So it will talk over HTTP and HTTPS. So you set up your Metasploit listener on the machine that you control. You run invoke shellcode, provide the payload. In this case, we're using HTTPS. Configure the IP that you're going to call out to and the port. It downloads the payload and sends the shell back out to you, all in memory.
So this, I think I've referred to this as the easiest way to get a shell like ever. So from any box on the internet, you can run that single command, and that's going to call out to GitHub, pull down the function, .source it, and run it just like that. That's all you have to do to get a shell. All right, so dumping hashes. The normal way, I mean, everyone should know a million ways to dump hashes because you run into lots of problems with this if you're a pen tester. The Foofus guys are working on some great updates. FG dump, PW dump. Those are great tools that have been around a long time, and they're still working on them, which is awesome. Tim and Mark wrote BSidesAugusta, which does volume shadow copy, and will dump those things off for offline analysis, which has become very popular lately. So with built-in tools, with BSidesAugusta, you're doing the same thing, but you've got to push that VB script, right? So you've got to write to the disk. So we wrote get password file, which does the exact same thing. Dumps those volume shadow copy things off for offline analysis, but you can do it from the command line. You don't actually have to upload the script. There's power dump, which was added to Metasploit. Dave Kennedy, which we didn't mention before, but Dave Kennedy's PowerShell talk from DEF CON a couple years ago kind of inspired us to start working with PowerShell. DEF CON 18, I think. He had the original execution policy bypass and all of that stuff. So he's been hugely inspirational on a lot of the stuff. I just had to use that top method. I don't know if anyone's ever done that. You can use reg.exe to save off HKL and SAM and system, pull them off and use SAMDump to pull the hashes out that way. But just a quick thing on get password file. It figures out whether it's on a DC or not, and then we'll dump the NTDS. We'll find the actual location of the NTDS and give you that. So it actually does pretty much everything for you. Taking screenshots. Doesn't matter if you own the DC, right? The CEO doesn't care. He wants to see a screenshot of his desktop. So when you have your own custom backdoor and you're not using Metasploit, this becomes kind of a challenge. So one way that I was taught to get around this is this little utility NERC command. Has anyone ever seen it? It's got lots of little built-in functionality. One of them is that you can take a screenshot. So I would upload this and then call it using the command wait, take screenshot, and then you would have your screenshot and then you download it, which was kind of cool. If you're uploading a utility, you're leaving stuff on the box, which you shouldn't do. I think I've had a call before where someone, like a year later, found their command on a box that I've been on, and they were like, did you leave this there? And I'm like, yeah, I'm probably the only person that ever uses that. So, yeah. So now we do it this way. So I originally wrote get time screenshot because I was doing something pretty fast paced, so I had a short window and I was going to be hacking a whole bunch of stuff, and I was using a Linux VM on a Windows box, and I'm like, I want to take screenshots every 5 seconds so that I can look at it and figure out what I did. So that's what I actually did, because stuff happens so fast you can't keep track of all of it. So then I can go back and say, okay, that's. So I like to keylog myself, which we talked about before, which was the inspiration for our original PowerShell keylogger, and to take screenshots. But it obviously can be used to go after remote boxes, take screenshots that way, and then pull them back.
All right, so pivoting. Once we've compromised the machine and we want to spread deeper into the network, we want to leverage pivoting to use one machine to compromise others. Typically, the way that you would accomplish that is with BSexec. That's the tried and true method. Again, that does get flagged, despite it being signed Microsoft executable. It's easily detectable, and it sends credentials over the wire. The way that we prefer to do it is using WMIC. So we'll queue up our malicious PowerShell command, and you can specify /node through there, and it will spawn PowerShell.exe process on the remote machine that you specify. You can accomplish the same exact thing leveraging WMI and PowerShell as well.
All right, command and control C2. How do you guys do it, pen testers? You get a VPS, Amazon, one of those methods. You can port forward through some, router or device that you purchase and put on the internet. You could get creative and create some fun attribution to maybe it's APT1. Get your VPS out of China, and so when they see the callbacks to China, they freak out. If you're a red team, that might make them take it more serious than they otherwise would. The minimalist way is, instead of standing up your own infrastructure, which is new and unknown, go use things that their users, their enterprise is already talking out to. So there's been a lot of recent stuff with Dropbox and Evernote, and all that stuff is awesome. It's exactly what I'm talking about. I've used Twitter before. I gave a talk where I introduced Info's Twitter bot, which just uses Twitter as a C2. It's a PowerShell script that will call out and look for specific statuses. Twitter changed their API, and I was using XML, so I need to update that for the JSON stuff at some point. But you can use Blogspot, Pastebin. But what I really like to do is look at their external infrastructure, look for some way that I can comment on something, look at their actual social media sites, their Facebook page. Is there something that they're going to that I could add something to, even if it's just a number 1, or great job? And then I build that stuff in, so great job equals command.exe. Bad job, this is terrible, equals run this command. You can build all that logic into the script beforehand, deploy it, and then your C2 is you creating a random user, posting that message. When it sees that message, it then does something that way. So you're using their own stuff against them. If they've got a wiki site, it's just too easy to go in there and do that as well.
So people are finally over using IRC for command and control.
Yeah, I mean, we typically use HTTPS because that's really the only way that you're going to get, most of the organizations that we would go against are going to have a proxy. So everybody needs to be proxy aware, and it's going to have to go through human, someone's going to look at all the traffic, so it needs to look more legit. That's kind of what we're preaching. Stay within, hide in the noise, look like they're normal traffic, and it's surprising how long you can live for long-term engagements. You can live for months and years in organizations using these methods. So just a few built-in tools, so we're not introducing anything that might potentially be flagged later. But yeah, Mimikatz is great the day that it comes out with a new version that doesn't flag AD. You deploy it and want to use it 3 or 4 weeks later when the signatures catch up with it. It flags, you're burned, they're calling in Mandiant to come find you, and that's bad. So use the tools that are already there and reduce your forensic footprint. PowerShell's awesome. Microsoft did a great thing. It gave defenders as well as offense an easier way to do things. But if you're an admin or a defender, all the ways that you can use PowerShell to make your job easier, I think are greater than the ways that an attacker are going to use PowerShell. We've only really seen one public example, Russian malware, that's using PowerShell. But I've seen organizations that are reviewing their logs using PowerShell scripts and quickly finding bad things on their network. We love any ideas that you guys have. Talk to us later or right after. Any ideas for scripts that you like written? At some point we run out of ideas of stuff to add to PowerPoint. I write defensive scripts and put them on my GitHub occasionally. So we're not just red team guys. So if you've got any of those ideas, or if you'd like to contribute something, by all means. So we'd like to thank all you guys for coming. This is great. And the organizers, the PowerShell security community is very small.
That's it.
That's it. Literally, unless there are people that are, I'm sure there are people out there that don't use the internet, but are doing PowerShell stuff. And then the authors, I think we've read every book that's out there on PowerShell. There's some great books and some great authors. And then those are our blogs and our GitHub pages and our Twitter handle. If you have any questions, we generally answer questions on Twitter. We're on there all the time. Emails. Shoot us an email. I'm obscuresec@gmail. Matt might want to give his email. Hit me up. Hit him up on Twitter. So my question is, what is the pun with Matt's blog name? Patch Tuesday. I think what one it's.
And if anyone would like to contribute PowerPoint, definitely talk to us because we're always seeking new ideas and new scripts to add to the module.
Anybody have any questions about anything?
Can we get a copy of the PowerPoint you presented today?
What's that?
Can we get a copy of the PowerPoint you presented today?
Sure. I'm going to throw it up on ObscureSec/presentations. So it'll be up there probably Monday, or maybe I'll get to it tonight. Yeah, and all the code, for the most part, is up on the GitHub. If there's anything else that you have a question on, feel free to hit us up. And if you see PowerShell being used by some malicious actor, and you want to just tell us that, that'd be great. I find that stuff fascinating, and I can put in 3 hours sometimes to help people. Any other questions?
You guys consider doing anything to do a reverse shell where like you've got something persistent in the network talking outbound to 443 somewhere else, and then you connect there, kind of come in on a triangle. So most networks aren't doing egress filter, so they'll never know it if there's something going on.
So, yeah, well, we typically go against organizations that have SSL stripping proxies. We do pretty high-end pen tests. So the people that we're going against, and kind of the reason that we've gone this route, and we pushed on PowerShell And staying true to the work hours of the organization, pre-com being super important to understand what's going on with those. Are they leaving at 5 o'clock? You know, do they have workers in LA? These are all things that we need to understand. But not only that, we need to survive SSL stripping and actual inspection of the traffic itself. They need to be able to look at it and say, this looks like real web traffic. If you could just pop a reverse shell out over 443 and not stay HTTPS compliant, then sure, why not do that? That's a good way to avoid detection in less secure networks or less funded secure networks. It really comes down to money, whether you can afford an SSL cost and have the people like you guys to actually go and look at the traffic. If you can, then you've got to get a pen tester or red teamer that can up their game to the point where they're not going to be detected by stuff like that. Just show that can happen.
Hit us up after this and we'll answer any.
Yeah, any other questions? We'll be around for a while. Thanks, guys.
Thank you.